Hello everyone, this is Kavyasri Debala, pursuing BTech first year in VVIT College. This video is completely for a similar purpose. Today we will dive into an important concept in data structures, particularly single interface. The topic I will be covering in this video is inserting a node at any position. Before starting our actual topic, first we need to know about single interlist. Single interlist is a linear data structure in which elements are connected sequentially. These elements are nothing but nodes. This is the node structure in a single interval. Each node is divided into two parts, namely data and the link. Data part consists of actual value of a node, while the link part stores the memory address of next node in the sequence. For example, I am considering a linked list with three nodes. Assuming that first node is stored at memory location 100, second at 200, and third at 300. Here, 10, 20, and 30 are the actual values of these nodes. Hence, they are written in data parts. While coming to the link paths, as we know, it stores the memory address of next node in the sequence. Therefore, 200 should be written in the link path of first node and 300 should be written in the link path of second node. And while coming to the link path of third node, it does not contain any value. Simply it points to light. In any linked list, head and tail are the two pointers used to manage the list. Head always points to the first node in the linked list. If we consider the same example, first node is pointed by head. This head is used as a reference in traversing the list, and also when the list is empty, this head points to none. I simply understand the linked list by comparing single linked list with one-way roads and double linked list with two-way roads. One-way road restricts the traffic movement to a single direction. In the same way, single linked list also allows the movement from one node to another node, that too in forward direction, but not backward. Vehicles can easily enter and exit in one-way roads very easily, but it is a bit hard in two-way roads. In the same way, in performing insertion and deletion operations on single linked list is easy when compared with double. But the actual reason is single linked list require updating of a one variable, but a double linked list required updating of two variables. By using these 6 steps, we can insert a node at any position. First, we need to allocate the memory for new node, and second step, assigning data value to the new node. Third step, set the next part of new node to null. Fourth step is read the position values from the user. Step 5, traverse the list to the node just before the target position. Step 6, updating the pointers. By using these 6 steps, let us try to write a source code. For writing a source code, a big question arises in our mind. How to store a linked list in memory? A linked list is stored in memory by using a self-referential structure. When one of the structure member is pointing to the same structure, it is nothing but a self-referential structure. A stored is a keyword used in C and other programming languages to define a structure. The name I am giving to this structure is node. We know structure allows a different data types to be stored together. Here, our data value consists of integer value. Hence, I have mentioned the data type as int. Our next part consists of memory address of next node, right? So it is a pointer. A pointer can be indicated by keeping star. So it is a pointer for a node. Hence, the data type is struct node. Here, one of the structure member is pointing to the same structure. Therefore, it is a self-referential structure of a single linked list. Now, it is a time to declare variables. First, I am declaring the variables which are in struct node format, as our step 5 consists of traversing the list to the node just before the target position. For that purpose, a head and temp pointer variables are declared here. Head is used as a reference in traversing the list, while temp is used to represent the nodes just before the target position, and also a new node pointer variable to represent the node which we are creating and inserting into the list. And value and pos variables are declared here, as these are integer values. Data type is integer. These values, which these two values are read from the user. Value stores the data value of the node, while the pos stores the position value which we need to insert in the list. A first step comes allocating the memory for a new node. So it can be achieved by using malloc function. If the malloc function is successfully executed, then it returns a block of address. Otherwise, it returns none. That means here there is a need to check if the memory is allocated or not. If the memory is not allocated, then our new node points to null. So here, if and else statement is used. If new node is equal to null, then it simply prints the message memory is not allocated. Here 2 equals to symbol is a conditional operator which checks if both the values are equal or not. When the memory is allocated, this else part is executed. Printf and scanf functions are used to read the data values from the user, and that data value is stored in the variable value. And that value is stored in the data part of new node. In a structure, when a structure variable name is used, then dot is used to access the elements. When the structure pointer variables are used, then arrow mark is used to access the elements. As we declared here structure pointer variables, therefore arrow mark is used to access the elements. So far, creating a new node is completed. Now it is the time to insert in a list. Here there are two cases. When the list is created, when the list is not created. So again, I am using if and else statement here. So earlier I have said that when the list is empty, then head points to null. So this is our condition. When it is true, our new node is pointed by head. What about when the list is created? When the list is created, this else part should be executed, and in which printf and scanf functions are used to read the position value from the user, and that position value is stored in the variable pos. And also a temp variable is declared and initialized to head. Here for loop is used to traverse the list to the node just before the target position. For example, here is memory is allocated successfully, then a new node is created. I'm assuming that this new node is stored at a memory location 250. If I have given the data value as 25, 25 is stored in the data part, and next part is set to none. If I have given here the position value as 3, then for I is equal to 1, I starts with 1. Pos minus 1 means its value is 2. Therefore, condition is 2, temp is equal to temp plus. First, temp is initialized to head. That means temp points to first node, that is 100. Here, 100 of next means 200. So, temp is equal to 200. Our temp is here. It points to the second node. I have given the position value is 3. That means this next part should indicate the new node memory address, and also new node next part should indicate the 300 as memory address. Therefore, this is 300 is stored in the next part of temp. So temp of next should be assigned to the new node of next. It is updated to 300, and also new node memory address should assign to the value next part of temp. That means here 250 is updated and successfully insertion is complete. Thank you for giving this opportunity.